Yes, I welcome you guys. Happy New Year. We are going to look at how we can solve exact differential equations. Yeah, this lesson taken time without being uploaded. I queued it, but it had not come. So, solving exact differential equations. Now, before we look at how we can solve them, we need to first look at how an exact differential equation appears to be like. Now, we need to know that an exact differential equation is that equation written in the form A, write it in the form A, then xy dx plus b xy dy is equal to 0. So this is the form in which exact differential equation is written. Okay, so it appears in that form such that there exists a function f of two variables x and y, which have continuous partial derivatives. Which partial derivatives we are going to get? The one of fx as equal to a xy and f of y as b into xy. So basically here, what I want to take you through, this one should not worry you. We are going to just aim at what the form is, and then this fx is this first part of A, then fy is that part of B. Now, we are going to ensure that we know how to test for exactness, and after testing for exactness, we can go ahead and solve these equations. So before anything else, I'm going to take you through testing for exactness. How do you know that this differential equation is exact? So I'm going to look at testing for exactness. How do you test for exactness? Now, to test for exactness, we use partial derivatives. We use partial derivatives such that curl A curl y is equal to curl B curl x. I'm not writing this is not D, it is curl. So this is what we call a partial derivative. You have to write it as bent D. So curl A curl y should be equal to curl B curl x. If they are not equal, then we shall not say that they are exact. We shall be transforming it to exact equation by multiplying an integrating factor, which is going to come in the due course. So now after this, after having tested for exactness, now we can go ahead and solve the equation. But let's first go into the practice of solving the exact equations, rather the practice of testing for exactness. After testing for exactness, then we can see what we are going to do as far as solving these equations is concerned. So testing for exactness, we must ensure that curl A curl y should be equal to curl B curl x, okay? And that one will take us to our examples. Show whether the following equations are exact or not. A, we have y plus x dy dx is equal to 5. B, 2xy cubed x squared y squared dy dx is equals to cos x. Then C, we have x squared dy dx plus xy squared is equal to 5x. So you want to show whether these equations are exact or not. For you to show that they're exact or not, you need to first know the main equation or the general equation which exact equations take. Then it is after you knowing that general equation that you are going to see whether this condition hold as far as those equations are concerned. So let's have the solution of these parts and then we see what we can do. Yeah, so solution part for part A. We are having y plus x dy dx is equals to 5. Now we're having this equation. This equation must be expressed in the form a xy, the general form, dx plus b xy dy, which should be equal to 0. Yeah, implying that this side we don't have a 5, we need a 0 there. Okay, so since we need a 0, we need to first pick this 5 and bring it to this side. So we shall have y minus 5. Yeah, we're having y minus 5 plus x dy by dx should be equaling to 0. Yeah, so we can multiply by dx throughout so that we have, you multiply because the LCM is dx. So multiply dx here, multiply it here, multiply it here. So we shall have y minus 5 everything times dx plus x. When you multiply here dx, it will be only dy, should be equaling to 0. Yeah, so implying that this form, our equation has been established in this form because we have axy dx, and indeed we have dx here. Then we have x dy, which is, so the form is executed. Now, after executing the form in which you want it, yeah, we need to know that this would imply that our axy should be equal to our axy, this only is y minus 5. So we shall have y minus 5, while our bxy is equal to x. Yeah, now looking at these two, we can get, we are going to look for cal A, cal Y, cal A, cal Y. Yeah, cal A, this is A already, so we look for cal A, cal Y. When we say cal A, cal Y, it means that you're differentiating A with respect to Y. So we have Y minus 5. If we differentiate it with respect to A, to Y, rather to Y, we shall differentiate Y, we get 1. Reason, we are differentiating with respect to Y. So it will be 1 minus, when you differentiate 5, we say that you get a 0, 5 being a constant. Then cal B, cal X. Cal B, cal X. When you now it means we are differentiating with respect to X. When you differentiate X, you get 1. Now, since cal A, cal Y, and cal B, cal X are equal, then this equation is exact. So you conclude and say, since cal A, cal Y is equal to cal B, cal X. I don't know, you'll be reading this. Some students find they say dA, dy. Yeah, but since we are using a partial derivative, it is read as cal A, cal Y. So is equal to 1. Then the differential equation is exact. As simple as that. So let's also try part B, and we see. Let's try part B and we see. For part B, we are having 2xy cubed plus 3x squared y squared dy dx is equal to cos x. Still, you need to bring this one, we don't want it because our differential equation must be in the form a xy dx plus b xy dy, which should be equal to 0, implying that we must bring this cos x this side so that we get 2x y cubed minus cos x, yeah, then plus 3x squared y squared dy by dx, and this should be equaling to 0. So we can multiply dx through so that the whole of this one is multiplied by dx. So we shall have 2xy cubed minus cos x dx, then plus 3x squared y squared dy, and this should be equaling to 0. Now, after having executed this equation into the form where we want it, now we can get the partial derivatives, right? It means that the one of a xy is equal to 2xy cubed minus cos x. Then the one of b xy is equal to 3x squared y squared. It would imply that if we need curl a, curl y, curl a, curl y is going to be equal to, meaning we must differentiate with respect to y. So this one with the cos x, we don't look at it because it's now like our constant. When you can differentiate cos x with respect to y. So we have 2xy cubed. When you differentiate it, this 3 will come here, it will be 6xy squared because you have to reduce the power by 1. Then curl b, curl x. You now with respect to x, so we are interested in the power on the in the power on x. So it will be 2 will multiply here to be 6. Then now x, but y would not be affected. So you realize that curl a, curl y is equal to curl b, curl x, which is equal to 6xy squared. Then the differential equation is exact. Yeah, that is how we are concluding. Then finally, let me do parts, then we look at how to solve them. Finally, we are having x squared dy dx plus x y squared is equals to 5x. So we need to first express it in the form a xy dy right? But now for this case, let me say dx, we are going to see y, then plus b okay, still we need it in the form dy, okay, dy, then plus b x y dx, this should be equal to 0. Now, of course, we must first bring this 5x this side. So we shall have x squared dy dx plus xy squared. Yeah, xy squared, we shall subtract this 5x. Don't bring it in dy, don't subtract it from dy dx. Yeah, so this should be equal to 0. Now we multiply the x through. So it means that we shall have x squared dy, yeah, plus x y squared minus 5x dx should be equal to 0. But now, wherever you have at the x, now this will be our a, because this is what we shall differentiate with respect to y. So it means that our ax is going to be equal to x y squared minus 5x, and our b is equals to x squared. So we look for curl a, curl y, meaning the derivative of a. So when you differentiate this, you get 2xy, yeah, 2xy. Then you also get curl b, curl x, which is going to be equal to 2x. Now, they are not the same. So you will say, since curl a, curl y is not equal to curl b, curl x, then the DE isn't exact. As simple as that. So we have seen how to test for exactness. Now, can we look at how to, we want to look at how to solve, yeah? Want to look at how to solve these differential equations after having tested that they are not exact. How do you, or rather after having known how to test for exactness and inexactness, how do you solve them? So let's wave direct to solving exact differential equations. Solving exact differential equations. Now, it means that for this case, we can start right away. Remember, we have already tested the exactness. I can use these very examples that I have. Yeah, you can use these examples that we already have, and then you continue. Since we have already tested for exactness in these examples, then you can continue from there. But if you have not tested for exactness, then you need to, yeah, you need to test for exactness. So, for example, I have, let me begin with this first part, y plus x dy dx is equal to 5. We have already seen, it was our part A of testing for exactness. We have already seen that, it is already exact. But if it is a question in an exam, first test for that exactness and show me that they are exact or it is exact, then you continue. But the fact that now we have already tested that it is exact, yeah, we have to look for the main function. Here, what makes learners fail these numbers is failing to tell what the main function is. I remember when I was introducing, yeah, when I was introducing, I told you that we first test for exactness. After testing for exactness, then we integrate the function that was differentiated to give the terms on either right-hand side or the left-hand side. So now, after doing this, after testing that a given differential equation is exact, it means that the terms on the left-hand side are as a result of the derivative of the main function. I don't know whether you're clicking. I'm trying to mean that after you having known that the equation is exact, or after you transforming it to exact by multiplying the integrating factor, it means that the terms on the left-hand side, these terms on the left-hand side, this is the left-hand side, are as a result of the integral, no, as a result of the derivative of the main function. So how do we get the main function? I need to first put like an NB here to show you what the main function is. The main function is equal to the integral, of the derivative. Okay, is equal to the integral of b, to be simple, is equal to the integral of b, which b is the coefficient of dy. Coefficient of dy. So the coefficient of dy is the main function. Rather, the coefficient of b is the main function. So we are saying that the main function is equal to the integral of b, meaning that we need to first look at what is b, then what is the coefficient. B is the coefficient of dy. So the integral of b with respect to y. For example, now for this, after having transformed it, yeah, after having transformed this this equation, yes, we shall have it that the main function is going to be equal to, for the case of this one,